So I'm Damien Smith. I'm from the Marine Institute. I've been the Marine Institute participant in the iMagine project, and basically we looked at some of the species stories, and basically looking at the prawn burrow detection and video quality analysis. Um, as we're part of EMSO. There's two other EMSO partners involved in the project, EMSO Azores and EMSO OBSI, and they both have done webinars as part of this series. So they're definitely worth watching. They use similar YOLO V8 model for their work as well. The EMSO group of partners working in the project, we looked at ecosystem monitoring at EMSO at the EMSO observatory sites, and our interest in EMSO SmartBay was to look at video quality in the observatory. We gather archives of video files and images, and we want to be able to, and we gather video in real time, and we want to be able to look at that footage and identify poor quality footage and good footage, and basically examine our archives and gather the data on what's in our archives that's of good or poor quality. And we also are interested in using object detection for species identification, and also for using object detection in fishery surveys, like the prawn fishery surveys, where we are using object detection models to investigate how these could be used in fishery surveys. The Marine Institute is an Irish government agency responsible for marine research, technology and development, and SmartBay is part of the Marine Institute. It's a facility off the coast of Spiddal in Galway Bay, where there's been a number of wave energy devices deployed going back a number of years. And then also we have an underwater observatory where there are a number of instruments and cameras and ADCP profilers, and a number of different instruments deployed. And then throughout the bay, there's also a number of buoys deployed, like wave riders and other oceanographic buoys. The SmartBay site has been used for a lot of different scientific studies, some of which are of relevance to the use cases in iMagine. We also looked at hydrophones and underwater noise. We also looked at phytoplankton, and there's a new phytoplankton logger to be installed in the observatory. We've had a number of underwater cameras and underwater sonar systems deployed at the observatory, and acoustic tag devices for detecting and tracking fish that have been tagged that have entered the bay. The SmartBay facility initially was used for wave energy device testing in 2006, and then in 2015 the cable observatory was installed, and a number of wave energy or a wave energy device was deployed at the site, and then and a number of oceanographic instruments. Different planning issues have meant that mainly the oceanographic and instrument testing role has continued on, but not the wave energy device facility at the moment. The observatory was damaged there in the winter last year, and it was retrieved in March, and it's planned to be redeployed in June. So, when the observatory is in operation, we have some web dashboards available at smartbay.marine.ie that are streaming the data that's been collected on the observatory in real time from various sensors like pH, CTD, acoustic Doppler current profilers, hydrophones, and then the existing video camera on the observatory, and there's a couple of more cameras planned to be deployed in the next deployment. The sort of workflow that we've had for dealing with the video footage, on the left you'll see sort of the representation of a camera that we have at the observatory, and the camera streams video to an Agile Hello appliance at the moment. So we've this video appliance that takes the video stream and writes the data from the video stream out to files in a file archive. And then we also have with HEANet, who are members, who are like a national higher education network provider, and they have a Wowza streaming server, and we stream the video to them, and from there it's streamed onto the internet, and then we pick it up on our website and display it on the web page. As part of the iMagine project, we're hoping to use the iMagine modules that we've developed in-house. Obviously there's the iMagine platform, but the iMagine modules have been developed with open source software and container based, so it allows them to be deployed anywhere that has open source software infrastructure deployed. So we have a Docker environment where some of the iMagine modules we've deployed we've created can be deployed in-house. So the idea is that we would use the models that we've developed in the iMagine project and use them to detect species, detect video quality events, and to stream that information into a database and then present it on our web dashboard. So maybe the video feed, much like EMSO SmartBay, might show the detections in real time on the video footage of different fish and fish species. And then also we would be recording video events, and that might alert if there's poor quality video and stuff like that. So just to get back to the how we deal with the video files in the observatory, we record 2-minute video files into an archive. So we've an archive going back to 2016. At the moment, we only have 2019 online, but we have that other archive available in-house. We record 2-minute video files, and you can see we record them to that particular pattern where we've an appliance, year, month, day, and then the sort of file format. So we've an automated routine that takes the existing 2-minute video files and does a frame grab of the middle. So 1 minute into the video, it creates a frame grab of what's in that video, and it saves it to the archive for that day. And then there's another routine then that also takes all of those images and turns them into sort of a summary video for the day. Obviously the observatory it is underwater. It's 25 meters underwater. So at that depth, you start you see a lot of light attenuation. The colors that we would see coming from the sun, and the reds, the greens, the blues, most of them are filtered out, and it's only really the green light that gets through to the bottom due to the physical properties of the water. And then also some days when there's after a storm or rainfall, we see those effects on the video footage in the observatory, where the water gets quite turbid, or after storms, and visibility decreases quite a lot. So these are just some of the sample frames of in our annotation environment, showing some of the better quality footage that we have. And using the annotation software, you can use some of the image enhancement techniques to better see what's in the actual footage, which is handy for anybody annotating the data. So as part of SmartBay's involvement in iMagine, we looked at we developed two marine species model. One is a more general look at what sort of marine fauna exist, and then the other sort of goes into a species level, trying to identify the typical species that are in the observatory. So we had a lot of work done last year by a couple of bursars, Eva and Ava, who worked on the observatory data and then also on the Marine Institute NEFROP survey data, and they went and gathered a lot of images from the observatory, but also the National Aquarium in Galway. And then we looked at Minca, a Spanish website that has a lot of which is gathering a lot of natural photos of different creatures and life forms, and basically it's like a social social platform for logging photos of different organisms, and a lot of the imagery is CC BY and can be used for researchers for different projects. We've more annotation work planned for the summer. And we see the models that we've created now pretty much as their initial form, and we'd hope to continue on looking at adding more data to the training data and improving the models. At the moment, the sort of workflow that we have is images that we've gathered, we're loading them into CVAT, annotating them, into the different classes, like fish, flatfish, stuff like that, or using the other projects in CVAT where we're annotating the species label then in them, and then we export those annotated data sets, and we've been using RoboFlow, and the online RoboFlow platform to help organize the data sets. You can import your data and then use it then to examine the balance in your data sets. I think Enoch and EMSO obviously has shown some of the approaches they've used for balancing data, and some of the issues that occurs with that. Obviously in an observatory, some species are more common than others. But anyway, we export the data then from RoboFlow in the YOLO V8 training data format. We bring it into a Jupyter notebook. We've been using a GPU environment on site, much like what is available in the iMagine platform, using the same technologies, Jupyter and Ultralytics for the YOLO V8, and then using that environment to create a model. We've also on the iMagine platform done some training as well. So this has one of the modules that we've deployed to the iMagine platform is the SmartBay marine types. This was largely done by Eva Cullen. The annotation and training data behind that was largely gathered by Eva. This at the moment has a small number of classes. We're hoping to add more classes to this module and the model over the summer. One of the things we discovered there recently is there's a nice open image data set which might suit these more sort of generic fauna models. So Google has a CC BY archive of open images, and there's a lot of classes that would be quite useful for a generic marine model, like obviously crabs and bird and fish are all part of this open images data set, and there's a lot of open source tools that people have developed around this data set that makes it easy to export different classes for use in your own models. So this is something we'd hope to look at over the summer as well. Some of the images are human annotated, and others have been annotated by different models, so they need a bit of review. The other module the species module we've deployed on the platform, at the moment there's about 30 classes of mainly fish species, and we'd hope to add up to 80 classes of sort of typical species that occur in Irish waters, and then also look at adding some of the other marine invertebrate species and the various bird and mammals that we have seen in the observatory footage. We've seen seals and cormorants and various diving birds at the observatory. So we would hope to supplement that model with additional species over the summer. For the video quality assessment, initially we were hoping this would be one of our main modules, but we didn't have much annotation resources to work on it. But when you're operating an underwater camera, you encounter a lot of issues over time where different algae can grow on the camera. We've tried using UV lights to suppress that, but over time your footage starts to deteriorate unless you have regular maintenance. And other observatories have deployed different cleaning mechanisms and that. So one of the ideas we had initially was trying to detect degradation in the video footage and warn about the degradation and schedule maintenance and cleaning and stuff like that. But the other thing then is, as you're gathering a large archive, we've been gathering imagery and video at night, and at some stage, this archive will get, or it is getting quite large. We're gathering nearly 1 terabyte a month of video footage. So, you really need to find what imagery do you want to keep, and what's good and what's bad, and what imagery can you remove, or video footage can you remove. So one of the things then over the course of the project, we decided that this wouldn't be something that we could work on, or develop further. So we looked at how some of the social media companies were analyzing the huge amounts of video that they were coming in, and there is this whole area of video quality assessment. And one of the top performing algorithms for video quality assessment is Dover. And we looked at implementing Dover, testing out Dover. So we built the Dover model and or downloaded it. It's a off-the-shelf model, and then there's some Python scripts then that come with on the Dover GitHub repository, and we ran them against some of our videos to see how they performed, or how were they assessed by the Dover algorithm. And as to be expected, an image or a video recorded at night scored quite poorly, whereas one during the day scored much better. Dover looks at technical and aesthetic features in the video, and you can go to their webpage or their GitHub repo, and it explains more how that algorithm works. So we've parked it at the moment. We tried to create a module on the platform, and then we decided that maybe the licensing actually changed there last year from an MIT to a more custom license. So we held back on developing a module on it, and we're looking at maybe deploying it locally in-house, and deploying it as a function in-house that we can pass video to the function, and it'll record the score to a database, so that we can the idea would be to run across our whole archive, or months, or a couple of months or days in the archive, and identify poor video and scores and stuff like that. So the other aspect of our work was we looked at the nephrops data. So nephrops are prawns, and this is in relation to the prawn fisheries in Ireland. And we have a survey team in Ireland that is responsible for going out to the various prawn fishing grounds and recording footage from those areas, and then counting the prawn burrows and using that to indicate the health of the prawn population. So they would look at prawn density, the density of active prawn burrows in these fisheries areas, and count them manually, and record the data, and advise the fisheries management and catch quotas and different things like that. So they deploy a sled off the back of some of our research vessels. It hovers above the seabed, recording sort of 10 minutes of video in these prawn fishery areas. And the researchers then examine this footage, and they look for the characteristics of a prawn burrow entrance, and they use that, they count them and they count burrow complexes. So they're looking for a crescent shaped entrance and then a delta of excavated material and then a particular angle, and then looking at the various multiple entrances and how they coincide with each other. They have their own in-house tool that they developed in OR, which is quite manual for marking and annotating the different imagery that comes in. Again, they're interested in looking at some of the burrow complexes and the burrow system. So you see this linear feature where you have two entrances back to back, and this is how it looks on in the sediment, as a vertical profile there on the right hand side. And then they also have T-shaped burrows, and they have various different vertical profiles within the burrows. But so as part of the project, Eva Melvin worked with the prawn burrow team and was trained up on identifying prawns, and then she annotated a lot of imagery from the Irish prawn surveys, and then we used that then to try out a few different models last summer. So there's an object detection model deployed on the iMagine platform that's based on the bounding box approach in YOLO V8, and then also as towards the end of the summer, Eva looked at using oriented bounding boxes. One of the issues we found, and we'll see it in some of the diagrams from Eva's work, is that trying to discern burrow complexes was confusing the model. So we ended up removing that burrow complex class, and if we can probably see it better here. So you see different features there in the top left hand side where Ava's tried to demarcate a burrow complex, and then we ended up finding that this meant that a lot of features were underrepresented, and the balancing across the different classes in the model wasn't very good. And then that Eva looked at undersampling, and then that seemed to cause more problems. So basically we ended up excluding the burrow complex class, and then the performance of the models improved, and because we weren't trying to get the model to identify these clumps of features, maybe with much more training it might have worked, but in the end Ava ended up using an oriented bounding box model and a Python script to detect the coincidence of the different burrow entrances together, looking at the angles of the oriented bounding box. So maybe this year we'll have a look at that more and see if we can do anything to add that to the module we have in the platform. So and then from Ava's Python script also looked at counting the burrows in the video footage, and then there's a graph there in the bottom left hand side that shows what the density was recorded at that particular station by manual counting, and then how this performed compared to what was counted by the model. So there was good coincidence in the data there, and so this is the module that we have on the platform, and there's 5 classes in it: closed burrow, crab burrow, gate kept burrow, etc. And that model can be tested out with different footage, and some of the demos now will show us submitting an image and submitting a video to that. So the other thing we've been looking at, CVAS, which is a tool also available on the iMagine platform, and we've deployed it on site as well, and we use it for our annotation, but it also can use serverless functions and existing models to help annotate data. So we've been looking at this, and we've for example there's using just the YOLO V8 with the COCO data set, sort of common objects in context, so it's detecting bottles in the footage. But we've also got the marine types model working, so we can pick out get it to pick out fish or whatever in an image, and then when you're doing your annotation project, you can be getting it to, so you might have particular species, and you can create mappings between the classes you have in your annotation project and what the model has. So you could say, label all these fish as cod or whatever in the image. So, you know, it's quite a promising approach to help reduce annotation time. So we're going to spend a bit of time getting that to work over the summer. And you know, as part of the iMagine project, and then also into the Digi4Eco project, we hope to work further on implementing the actual infrastructure and deploying the models in-house, and creating the species databases and the event databases that we're going to stream to our web platform. So we're hoping some of this work will continue on under Digi4Eco. So I'll show some of our videos of our module in action. So the first video is to show the module deployment on the prawn burrow module deployment on the platform. You know, how to deploy a module, and then so it's deploying an inference module in this video, and we're going to submit an image to the module, and see what predictions come back from that. So at the moment, this is me spinning up a container on the iMagine platform that's running the burrow model. And you can pick how many CPUs or GPUs that you're going to use on the iMagine platform, which GPU you want to use, or no GPU, because some of the models are, you know, are quite performant even with CPU. So in this particular case, we use the CPU model. You can pick if you're going to attach to storage you have in the cloud for, say, training or different things like that, or where you want to store stuff. So this is the model. The model is deployed. There's an existing one running, and this model now is starting up on the iMagine, or this module is starting up on the platform. So that the module started up, and then you can connect to the module. So the module has a web interface. So this is the DPaaS API, where you can use the Swagger interface to discover how you interact with the model, and you can use that to test submitting images or video to the model, and then or to the module, and then the module uses the model to detect what's in the actual footage. So in this, I've submitted an image to the module, and the image has been uploaded into the module, and now the model has been run against the image, and it'll produce the detections. What has it detected in the image? So the first one, I selected JSON. I wanted the results out in JSON. So as part of the Marine Institute infrastructure, we would hope to be taking JSON of the various detections, and using that then to populate data flows, and push the data into databases, and use that in our dashboard. So you can see that it's listing the detections in the JSON and the bounding box of them, and what class was detected, the class ID, and then the confidence level, you know, how confident it is of what it's detected. So it's detected 2 prawn burrows in that image, and it's you know, you can see them then in the JSON, and their confidence intervals then, or confidence values there. So the next part of the video, I'm going to submit the image again, but I'm going to ask for the output as an image. So we want to use the module to take in the image, and then draw the bounding boxes on the image itself. So you can see there that it's basically detected 2 prawn burrows, and the same confidence levels appearing on it. So this will be useful we'd hope to look at using CVAT for instead of or trial using CVAT instead of the in-house software they have for counting burrows, and you know, use the burrow model then to help identify burrows, and then the operator can choose to accept the different annotations or not. So the next video then is just maybe, you know, uh, this video basically is showing how you can actually run the module in-house. So from the module page, you can find the link to the GitHub repo describing how to launch the module from Docker. It also has links to the dataset pages on Zenodo describing the data and the dataset, the training data where you can download it, and also the models. The model can be downloaded from Zenodo, and this is the Docker command for basically running a local container image of the prawn burrow module. So this I've launched this in Windows Subsystem for Linux. It's running a Docker version of the container, and we'll see the same web UI available now on my local machine. And from there, I can upload, I can, you know, look at some video that I want to submit to the module. So this is the unannotated video. I took 10 seconds out of one of those sort of 10-minute videos that we have. And then basically we're going to submit the video to the module, and it will analyze the video then, and it'll you know, place bounding boxes around the different classes it's detected in the video. So what's nice as well is you can see when you're running it locally, and if you look at the Docker output, you can see it detecting the different features then within the video frames, and it takes in the video frames and it seems to re-encode them then with the bounding box information on them. So that should be the 10 seconds of video encoded, and you can see there's a download file link there. There's a download file link that I was trying to find myself, but it's there in the response body, and you can save that file locally, and then you can review what the model has picked out in the video footage. So this is, I'll try and skip ahead. I was trying to find the directory myself. So I should play the video now sometime soon. So you can see that it's you know, it's detected the various classes there in the video footage. So I'm just slowing down the video there. They're recorded at 12 frames a second, I think. And so there it's saying it's a gate-kept burrow, which is a burrow that has a prawn sitting in the entrance. And yeah, so that's that there. So now I'll just show you, with much the same as what we did with the Nephrops burrow module, we can also do it with the marine types module. And I took some sample footage from the observatory that had I think it's a starry smoothhound shark in it, and then basically passed that video file into the marine types module, and you can see it picking up the shark eventually. I think we need a lot more training and of the model using observatory images, and for it to be able to pick up the features a bit better. But you can see that it's picking up that shark using the marine types features. So so that's me.